Here is going to be problem number 3. One second, let me pause. Construction crew at the new U Hart building by a rope and beam as shown. Right, so this is this load. The pulley is frictionless, which means that the rope has the same tension on each side of it. So we know that those forces are going to be equal to it. The dimensions are XAB is equal to 2.5 meters. Right there, or 2.5 meters, another 2.5 meters here, another 1.5 meter, and the mass that's being supported is 75 kilograms, which really isn't all that much. I should mention that the beam, the beam is 75 kilograms. Here's the mass here. Okay, so we do have a mass at each section. Okay, that's cool. That's good to know. All right, so we want the tension in the rope, and we all want the reaction at point A. So let's do it. So here we got, this is page 3 that I have going on here. And my name is Dr. Deal. Ted to my friends. Always been Ted. This is the spring of 2021. We are ES110. And I am homework 11. And if we get to know each other better after you graduate, and we are in the kind of relationship where we know each other, you can call me Ted, but not until then, because I think it'll help your education if we maintain a more formal relationship. Otherwise, I would totally be your friend. Totally would be. I am one of the nicest people you'll ever meet, and I sincerely say that. You just don't know. I care about people. I try to treat people the way I want to be treated. I go out of my way for people. But, I don't know. I also, just like anyone, I could be a bit of a jerk. I try not to be. Really don't want to be, but I recognize that about myself. Try to become a better person all the time. I think that most people can kind of say that. I'm not unique in that respect. But I do think the job I'm doing is sort of the sacred thing. To be a professor in mechanical engineering, or in any kind of engineering, it's a difficult thing. You don't do it for the money, right? You do it because you care about other people and you want to see them succeed in something that's very difficult to do. So, if it was easy, anybody could do it. I remember my boss telling me that right there, and those words stuck with me. His name was Bill McCarthy. He passed away. Is it going on 15 years now? I think so. And he had mesothelioma, which is a cancer that you get from asbestos. And it definitely got it from asbestos because he worked on board ships and in shipyards during the Vietnam War. And he was surrounded on steamships by asbestos. They even had occasion to throw it around in a funny way, and I guess that really wasn't that funny when everything was said and done. Okay, so this angle right here is 2 and 1, and the givens that we have here is that we'll say that this is M right there is going to be the mass. I'll call it MD. MD is equal to 250 kilograms. We'll say that XAB is equal to 2.5 meters. XBC is 2.5 meters. Well, there you go. We could have said they were equal to each other, couldn't we? XCD was equal to 1.5 meters. And I could have given you this angle right there, but I didn't. And I can see that mass of, I called it AD, that's the mass of this whole thing, is going to be 75 kilograms. So we want to find the force of the tension, and we want the reactions at A. Very, very, very standard problem. Important things to be capable of doing. Maneuvering through a problem. I think it was a pretty good problem to pick. Sometimes I'm not so sure which problems I should pick and which ones I shouldn't pick. This one, I'm feeling pretty good about. We'll define an FBD. We'll call it an FBD. We'll say what X and Y is going to be. We have a force that's going to be in tension here, and a force that's going to be in tension right there. So we have FT and we have FT at both of these things. We will have a reaction at A in the Y direction here. Because this one is coming kind of that way, and we may want to kind of like draw it up to make sure that the thing has an angle, we know that we're going to have a reaction over here in the opposite direction. So that's going to be RAX. And then this one, we could call it WD. And then this one too, let's try to get this thing so it looks like it's in the center. I didn't really quite do the proportions of this right. So this is 2.5, 2.5, and 2.5. So the center might be somewhere like right there. So this is going to be the weight of AD. And so let's try to see if we could dimension this thing out without getting things in its way. This is 2.5 to right here. Okay, this one right here is going to be 1.5. And let's see, these are all meters, so I guess I didn't write what that was. In between here is 2.5. But the whole length of this is 2.5 plus 2.5, that would be 5, plus 1.5, that's 6.5. So 6.5 is going to be the distance between here and here. But let me subtract out. Is that fine? Is that okay? I think it's okay. I'm just a little unsure. This is 2.55, 6.5, 6.5 divided by 2. That's what I thought. 3.25. 3.25 minus 2.5. And I get, this is 0.75 right there. Okay. For some reason I made a mistake in this. Let me figure out what the weights of these are. I could just leave them as masses and multiply, but I saw many people get this wrong. The weight here of this thing is 250 times 9.81. And that's 2,453 newtons. The weight of the beam, M, and I should have been this AD. This is the beam. No, that was the, sorry, D. This is AD times G, right? Is 75 times 9.81. Right? So that should be 735.8 newtons. Right? So let me write out, take some space up here. Sum of the moments about A is equal to 0. And we will have clockwise, let me start with him. He's the biggest one. 2,453 times this whole thing right here. So that's going to be, what did we say already? 2.5, 2.5, 1.5, 6.5. Great. This guy's also clockwise, and he is 735.8. And now we're going to go 6.5 divided by 2, 3.25 meters. We have this guy right here. We don't know him, but he's going positive because he's going counterclockwise, and that's going to be the 2.5. And then we got this guy, and got to be careful here because we were told that this was 2 over 1. I don't like these sort of things. I would prefer to have an angle. So I'm going to call an angle right here, and I'm going to write them really small, and I'm going to say that's going to be rise over run. So that's the inverse tangent of 1 over 2. That ends up being 26.57 degrees. I just prefer doing that to then trying to play around with these ratios. You totally could for the ratio, but it just bothers me. I don't know, just force a habit. So anyway, so that means that this thing right here has got an angle of 26.57 in there. So I only want to use the one that's perpendicular to my it's going counterclockwise. So it's going to be 2.5 and 2.5. So times 5 plus ft. It's only going to be the cosine of 26.57 times that distance of 5 equals 0. I got to tell you, I've watched many people struggle with the thing I just did. So if you don't understand it, let's have a meeting together and let's like work through how would we try to organize your thoughts to try to make sure that you get that same answer. It's an important milestone as you're going through the thing, right? That you break this thing apart and you start to piece this together. This is probably, I would say, the most important class, most important homework assignment that you have in this semester. This is, if you can do this, you could probably work through some of the harder problems if you could think your way through this particular topic. I almost think we maybe should get rid of some of the other topics in the earlier part of the course and just really hammer home this skill set, because this is what I see students lacking and what I find to be the most important thing that you have to work with. But I will not hit that any harder. Okay, so I have that. I'm going to take this 735.8 times 3.25. Add them together. So those two things. Now I have to divide by 2.5 plus whatever that's going to be. So I take the cosine of that angle times 2.5. Nope, darn. Times 5. Then I add it to 2.5. And I divide. And I probably made a math mistake somewhere. It's a good chance of it because I just made a little hiccup here. So, math mistakes are part of the thing we're trying to learn not to make, so they count. Not a lot, but they do count. So I got that together, and then I take my 26.57, the cosine times 5, and I add it to 2.5, and I divide it, and I got the same number. So I have a pretty good idea that that's going to be the correct tension. Now let me get the sum of the forces in the y direction equals 0. My reaction is RAY. I don't know for sure that it's going to be up. There's a chance this is going to be down. I just chose it in the upwards direction thinking that's got to be right, but we don't know for sure. So, because we have these guys competing with these two guys. So let's take it. I got RAY up, FT going also going up. That's at 2630. we have this one, but then he's also going up. But he's going to be the cosine of our 26.57. Now we also have that coming down, which is going to be our 735.8. We also have this going down. And that's going to be our 245. Oh, I got my comma in the wrong spot, and my hairs are falling out. 2453. 24. Oh. 2453 equals 0. All right, so let's see what RAY equals. We could be in the wrong direction. So I have this guy, and I accidentally wrote that plus. It is to, no, that should have been plus. They should both have been plus right here, because this one is going up. That one is also going up. That's going down. So let's get these right. Okay, yep, that's going down and that's going down. Did I get these right? A double, triple check. Okay. 26.57 cosine times. I'm going to add those two things together. That's a lot. I think we're going to end up with a negative number here. Let's take out the 735.8, subtract them, and the 2453, subtract them. Yeah, sure enough. That's interesting. I just want to think through this whole thing right here, because that is an interesting dilemma here. Both of those things coming up. All right. I guess that makes sense. We're almost like a teeter-totter, where this thing is in the center. This is pulling down, so this has to pull down, right? If you think about it in one respect. Okay, so I have I get a negative 1,793 pounds, which is going to be 1,793 pounds coming down. And then summation of forces in the x direction equals 0. We say our RAX, and then the only thing we have coming in the negative in the x direction is going to be a negative FT, which is 2,630, but it's only the sine of our 26.57. So we get an RAX of 1,176 pounds, and as drawn, that direction. So let's write out the answers. For part A, the force of the tension is going to be 2,630 pounds, and I'll keep writing out that it's tension. B, we're going to get that RAX is equal to 1,176 pounds. RAY, and this is the surprising one, is 1,793 pounds and downwards. And I probably should have gotten the magnitude, direction, magnitude, angle, and quadrant, but it's been a long time, been a long weekend, and I'm going to leave it like this way. It's just as valid to be saying that it's there. So there you go. Here's the solution to this problem. This is a really important one, so make sure that you're able to do a problem like this. That's it.